Mhm.
Get started. Well, welcome everybody. Thanks for attending this webinar. My name is Andre Austin with Scott Laboratories, and we had decided to put this webinar together. As I'm sure you all well know, hard seltzer has become a pretty popular product in the last few years, and due to that, we've started to see a lot of inquiry and questions in the hard seltzer production area regarding microbial control and how Velcorin technology can help with that. So fortunately for us, today we have a guest speaker, Dr. Michael Dahmen from Lanxess, the manufacturer of Velcorin, who's going to present for us some information on Velcorin and microbial control pertaining specifically to hard seltzer production. So thank you, Michael, for joining us today. We also will be doing a Q&A shortly after the presentation. The presentation should be 30 to 35 minutes, and then a Q&A session afterwards. There is a Q&A box at the bottom of your screen. If you have any questions during the presentation, feel free to put the questions there in the box, and we'll be answering those as we receive them. So if we don't get to your questions in the allotted time, I think we have reserved an hour today. We'll certainly follow up with you via email or after the presentation. So thanks again. For those of you who do not or not familiar with Scott Laboratories, we are the distributor of Velcorin. Scott Laboratories has been in the wine and alcoholic beverage industry for several years, actually for over 80 years. You might know us as a supplier of fermentation products, filtration products, equipment, packaging, many types of products in the wine and beverage industry. I'm Andre Austin. I'm the general manager of the Beverage Integrity and Filtration Department. We handle specifically Velcorin and filtration media for those industries. As a little bit more background with Velcorin, Velcorin has been a unique and very popular product recently. I'd say, well, recently, Velcorin has been around for more than 40 years, so it's not too recent. We've distributed it in the United States since 1988, starting in wine. But it's also grown into other beverage sectors within the various industries. So there are approximately more than 260 installations of this technology around the country, and also with mobile services and custom co-packing plants. There are probably, we estimate, thousands of product lines that are currently using Velcorin in the United States. So it has become a proven product for us. And with that, I'd like to introduce Dr. Michael Dahmen, and he can introduce himself, give you a little background, and then start the presentation. So take it away, Mike.
Yeah, perfect. Thanks a lot, Andre. Well, yeah, good morning, good afternoon, and good evening to everyone joining this webinar today. And thanks a lot to Scott Laboratories for hosting this session. Yeah, today I'm happy to talk about hard seltzer, its production and its microbiological risk profile. But before we get started, I just would like to introduce myself briefly. So my name is Michael Dahmen. I'm a brewing and beverage engineer by education. A little bit more than 4 years ago, I joined Lanxess as head of technical support. Before that, I worked for several years in different functions as a process development engineer in R&D for PepsiCo and Krones, the filling machine supplier. And today's topic I really like because it somehow is a good mixture of all different topics I dealt with in the past. So I guess this is the perfect link to what is on our agenda for today. So for roughly the next 30 minutes, we want to talk about the characteristics of a hard seltzer product and look a little bit into the hard seltzer market. We want to touch base on the risk profile of hard seltzers for sure. And then we will look how can we deal with those risks by the application and implementation of Velcorin Technology. And as Andre said, we will have a Q&A session at the end. Please use the toolbox and hand in your questions as we go through the slides. Okay, perfect. Yeah, coming to the characterization of hard seltzers. So there is not really a legal definition for hard seltzers, but there are some common features. So hard means containing alcohol. It's usually between 4 to 6%. Seltzer means carbonated water. And the alcohol base is usually coming from a fermentation process. This is quite different to alcopops, which usually has distilled alcohol. The primary source for the alcohol is sugar cane. Malt and wine bases are less common, I would say. Most of the products are acidified. They contain natural flavors, and they have a minimal sugar content. It's only up to 2 grams per liter, or even some sweeteners are added. So the overall calorie level is around 100 per 12-ounce can, and these calories are mainly coming from the alcohol in the product. Looking to the market size for hard seltzer, by far the biggest market is the US, 70% of the total share. But we see in Europe, especially UK, Scandinavia, Germany, some growth and getting traction of the product, Australia, South Korea, Singapore as well. In Germany, it's always a good indicator for product trend if it really gains traction. If the big discounter chains like Aldi or Lidl are going into that market segment, which they did this year. And another interesting factor, I think, is that also the Coca-Cola company is started with product launches in some countries in Europe. And in 2021, they, at least according to some press release, they preparing their launch in the US as well. So quite a very interesting market, and I guess this is related to the numbers we see on this slide. So in 2019, the global hard seltzer market was around 4.4 billion, and the expected compounded growth rate in this segment will be 16.2% until 2027. So as the US market is holding 70% of that share, the market will reach a number of $7.6 billion in 2025. So I guess this is why not only big global players are really interested in that segment, it's also the smaller breweries which found their space and niches in that market segment. Clearly, a big benefit for hard seltzer products is the kind of positioning in the market. So we see a lot of social media and influencer marketing. The product is stylish, trendy, new, perfectly fits to younger consumers because of the lower alcohol, the lower calorie level. So while beer is more of compared to beer, it's more a gender neutral drink, and as it contains less alcohol than wine, it's from calorie level beneficial. So another aspect, finally, and then we are done with the marketing part, is the convenient packaging. Yeah? So it has a good accessibility in the market. It fits very well to different consumer habits with the small cans for in-house and outdoor consumption. So overall, a very attractive marketing package which is coming with this product. But now we are looking into the manufacturing process of hard seltzers. And I guess the reason why it's very popular for breweries and wineries to think about going into this segment is they have some of the equipment already installed in their facilities, and they are used to fermentation processes, which is always the starting point for hard seltzer. So in this tank, you will have your sugar base, which is fermented to alcohol. The most important thing in this first step to consider is that you may need a certain acidification, because during the fermentation, of course, CO2 is occurring, and that will need to be buffered by some acids in your water sugar solution to keep the pH value above 4, which is ideal for most of the yeasts. And as the sugar only provides a carbon source, you may need to add some nutrients as well. So a mineral source and for sure a nitrogen source to ensure the optimal environment for yeast growth in this stage. Basically you can select your yeast strain most likely according to some economic aspects. So you want to have a very short fermentation time, and you want to have the maximum alcohol level without producing any undesired fermentation byproducts in that stage. So there's some know-how for sure needed in this first stage, to adjust conditions to an optimal stage and to select the right yeast strain. Once this fermentation step is completed, the yeast is removed either via filtration or centrifugation. So you have a relatively clear solution after the first treatment step here, but you want to get rid of the maybe off notes which occurred during fermentation. So that's why a second filtration step via an active carbon filter is very often used to get really a pure alcohol solution in that stage. Maybe some recipes want to have a certain taste coming from the first fermentation step, but in most of the cases you want to have a very neutral solution, alcohol base, because with the blending process you are going to adjust that one. And this is basically the second stage of the production process. While the alcohol base is transferred to the blending area, water is added at that stage to get to the desired final alcohol level of the drink. Sugar or sweeteners are added here, and the natural flavor. In most of the cases, it's a natural flavor because that fits very well to the marketing concept. Once the blend is ready, it gets cooled down and carbonated. And from that inline mixing skid, it's directly transferred to the filler. I think by far the most popular packaging format are cans, but you can find glass bottles as well. And then once the product is in the can or in the bottle, you have your seamer or capper to close the package. Looking to the risk areas here during production, usually when a contamination is coming from that blending or processing step, we call it a primary contamination. If it's related to the filling area or packaging area, it's called a secondary contamination. And how to control that, it's shown here on the next slide. And this is basically some really, I would say, basic stuff you want to consider producing a hard seltzer product. On the one hand, you have intrinsic factors which are related to the spoilage risk of a product, and these are really purely related to the recipe. And then we have extrinsic factors. These are factors you can adjust as a beverage manufacturer. But let's look into detail on this so-called hurdle concept, which is coming from the recipe itself. So very powerful hurdle for sure is CO2. So usual range is more here on the upper end with roughly 5 to 6.5 gram per liter. The lower range we saw only in one product. Why is CO2 so powerful as a microbiological control tool? Because all the microbes which need oxygen or aerobic conditions, they are excluded from any growth in that product. So CO2 will take care of all the molds, they are gone, and also acetic acid bacteria, which are also very common in the beverage production environment, they are controlled by the CO2 level. The next very, very important factor is the pH value. Here it's more on the lower end. So most of the products are clearly below 4 from a pH perspective. Going to the, because you simply can control your pathogenic bacteria with the pH. If you go to the low upper end, then it's going more or less into the low acid product category, which is defined by the FDA with a pH level of 4.6. And most of the manufacturers want to avoid that to go into this area because you have to consider additional measures in your production process producing low acid products. So CO2 and pH, very powerful tools. Most of the microbes are controlled by that. So what is the remaining spoilage risk? It's mainly yeast and to some extent lactic acid bacteria. Yeast for sure can deal with an alcohol level between 2.5 up to 5.5%. For sure all the strains used for fermentation, they will easily grow and consume the residual sugar, which is still present in the product. So when we look to all the hurdles, still a certain spoilage risk is present for hard seltzer, which needs to be controlled by the extrinsic factors. So these are the factors which I can control as a manufacturer. The first thing is for sure cleaning and disinfection procedures. It only makes sense to start production if your equipment is clean. So you choose the right temperature, the right cleaning agent with the right concentration. You want to have the right flow rate and contact time to ensure the proper cleaning and disinfection of your equipment. Then the raw material for sure is important, and especially with a product with that high water content, the water quality is critical important. And if you use, for example, reverse osmosis, UV treatment, ozonation for the water, and the rest of your raw material is in pretty good microbiological conditions, the whole incoming load of the product, the incoming bioburden is so low that you can avoid another treatment step of the product, yeah, either heat treatment or filtration. But it's pretty much depending on raw material quality and cleaning and disinfection. And finally, not to forget the process and filling equipment design. Yeah, if you have a rather old filling equipment with a lot of dead areas, which is hard to clean, then this becomes a critical important factor which needs to be controlled somehow along the way with your production process. And how is that gap controlled, yeah, with the equipment and the equipment design? So looking to you have done all the things right from the beginning. You have a proper water quality, good cleaning procedures. All the raw materials have a low microbiological content. So what is happening here in the filling area? Well, we have the packaging material, so either cans or bottles and cups and lids, which are coming into the filler. And in this filling zone, the product gets in contact with the surface of the filler and of the packaging material. So there will be naturally a certain pickup of microorganisms. And of course, during the transfer, the bottle or can is open. The time is, depending on the equipment, rather low, but still environmental air gets in contact with the product. And as I said before, these secondary contaminations coming from the filling area, they are the most critical ones, because with all the measures you have done before, what enters the product here will stay in the product. If it's a spoilage microorganism, for sure it can grow and ruin your product. And actually, a lot of research has been done especially by brewing institutes, to monitor the amount of secondary contamination in that area. And approximately half of the failures in a product are coming from that area. And why is that area so critical? Because transfer time and surface maybe not that highly loaded with microorganisms, but in that filling area you have a lot of aerosols which you form during the filling just by water spraying and releasing pressure from your filling tubes. So for a carbonated beverage, usually once the product is released from the filler, foam can occur. And this foam could be trapped with the cap or the lid in the neck finish of your container. That's why a lot of carbonated filling systems have a kind of neck flashing system to get rid of the product residuals. But on the other hand, you create droplets in that zone, which may get loaded with microbes, and they can enter into the product. And of course, between the outfeed and infeed star wheel of the filler, filling tubes are getting blown out just to get a proper filling for the next bottle entering the filling valve and to increase the filling speed. Also with that operation, we have a lot of aerosols in that area. So overall, that can lead to a scattered infection in that area. I mentioned already the air, which is around the filling machine. Sometimes you have a air filtration system in your production hall, which again limits the amount of microorganisms coming into this zone. But in many cases, you find an open filler environment. So air in contact with the aerosols or the product itself may contaminate your product as such. And finally, sometimes you have a packaging treatment system. Maybe you rinse with a chlorine solution or ozonated water, the cans or the bottles, as well the caps and the lids. But if that doesn't take place, of course, you have a higher microbiological incoming load via the packaging material. So overall, this secondary contamination needs to be controlled, and it's key for product stability. Yeah, how to control that secondary contamination? I just added one tiny piece of equipment into the flow chart I showed before, and this is a Velcorin dosing unit, which looks quite big here on this schematic drawing, but it has more the size of a vending machine and is by far smaller than the filler. Yeah, why do you need that machine? You need the machine to dose Velcorin. And Velcorin is a liquid. It's a so-called cold sterilant to ensure microbiological safety of your product. So the Velcorin and the mode of action I will explain on the following slide. But to have a closer look to the dosing unit and to understand the working principle of this machine, which is really independent from the rest of your process equipment in the filling line, you see the product would come in here. You have a mass flow meter measuring the flow of the product, and in this housing there's a membrane pump installed, really allowing a very solid spray of Velcorin, which is liquid, into the product stream. We need that dosing unit actually because the density of Velcorin is higher than water to get really a proper distribution of the liquid in the product. And it needs to be highly accurate. You can imagine it's only 250 ppm at a maximum dosage rate here, and this needs to be really going into the product very precisely. Yeah, the dosing unit as such can be easily installed into new and existing lines. And the benefit, and we see that really very often, that people having already a filling machine which was built for filling carbonated products, they want to go into the area of more microbiological sensitive products and fill them on the same equipment. And here it's a perfect addition, to install a dosing unit, because this allows you to fill the product safely from a microbiological perspective. So that means extending the portfolio and higher equipment utilization rate. The mode of action of Velcorin, or the working mechanism, is quite easy. So Velcorin is the molecule here in the center. Velcorin is our trade name. It's dimethyl dicarbonate, or DMDC, the chemical name for the molecule. And once this is added to the product stream, it will find the microbes, and it has the ability to penetrate through the cell membrane of the microorganism and block here relevant enzyme groups. And these enzyme groups are critical for the metabolism of the cell. If those are blocked, the cell will simply die off. This is related to the microbiological kill effect. The residual amount of Velcorin breaks down into methanol and carbon dioxide as soon as it comes in contact with water. So we have a proportional reaction here. Velcorin plus water. If you put in the maximum dosage, 250 ppm, you will end up with 120 milligram methanol and 164 milligram carbon dioxide. Both are naturally occurring in beverages, and that's why Velcorin at the end is not present anymore in the product. So this is a big difference between persistent preservatives, which just stay in the product. This reaction of hydrolyzation of Velcorin takes place slower or faster just by the means of the temperature, as most of the chemical reactions go faster with a higher temperature. It's here the same. So if we look to this graph and we see the three curves here, at the beginning, once it's added, you have 100% active Velcorin in your product. And if we follow the red curve here, this is at 68 Fahrenheit. After 17 minutes, 50% of the Velcorin is still active in your beverage. And once it's more than 90 minutes in contact with the beverage at that temperature, it's fully hydrolyzed. At colder filling conditions, which may be used for carbonated products like hard seltzer, the hydrolysis is a little bit slower. So if we follow the light gray curve here, 100% active at the beginning, 50% activity after 40 minutes. And then after 4.5 hours, it's completely decomposed into methanol and carbon dioxide. And even with a very low filling temperature of 4 degrees, it takes 8 hours roughly, and then Velcorin is gone. So once the product is in the supermarket, Velcorin is fully hydrolyzed for sure. Now, looking into efficacy data of Velcorin, which is very important, as I mentioned before, especially the yeast strains need to be controlled by Velcorin. And there was a lot of research done internally for sure and by external institutes, universities, and we picked some of the data which are relevant for hard seltzer products. So the strains used for fermentation, typical Saccharomyces cerevisiae or Saccharomyces bayanus, can be easily controlled even with very low dosage levels, 30, 25 ppm. You have a sufficient kill rate already. A lot of you coming maybe from the wine business know Brettanomyces as a very critical yeast to control for all alcoholic beverages, because it just develops very slowly in the product. It can grow even with high alcohol contents in the product, and it's really producing a very disgusting off flavor in the product. Really, the critical thing is Brettanomyces is often not detected by routine microbiological analysis. So product is already released, and some weeks later you will find out that there was a contamination occurring in your product. The other yeast strains which are mentioned here, Candida, Schizosaccharomyces or Pichia, they are also very common and different environments in the beverage manufacturing industry. So all of them are very well controlled. If you think about hard seltzers with a higher pH value, then also lactic acid bacteria could be a concern. And also for that, we have a proper control with Velcorin. Maybe the most common and well-known Lactobacillus brevis, which is present in almost all brewery environments. And really very, very often you will find that one in the filling area when you do the swab samples after production. So how do we support you with the implementation of Velcorin? So your first point of contact for sure is Scott Laboratories. They are supporting you with the lab trials if there's a need to carry out one. At the same, if you do a lab trial and you are really interested in doing scale up for commercial production, we would also recommend to do a plant assessment at that point in time, just to see what is the right dosing equipment for your product flow, to look for a good location to install the dosing unit. And for sure, when it comes to plant trial, there's a loan unit supplied for that to carry out such a trial. And even if there's full-time support during the plant trial, all the employees working with Velcorin are proper trained to make sure that everyone understands the working mechanism of the product, and also to get a good knowledge about the dosing unit as such. After the trial, of course, you will collect your own samples, do microbiological analysis. You may do sensory analysis with the product. We always offer as a service to check the methanol level, because with the methanol we can calculate back if the Velcorin dosage was accurate. So there's a whole service coming already in the project stage with the product. And then once you decide that's a very good fit for you, you want to install a dosing unit, then of course the commissioning is done of the Velcorin dosing unit by the team. At least you will receive annual training. All the employees get a safety training. They can ask questions regarding dosing unit, the operation principle. Maybe new employees get a special training for operating the system. So we will take care of that. And again, if there's we have microbiological labs in the US, in Germany. Here in Germany, we would also offer service of identification of unknown microbes. For example, if something new occurs in the production environment, we can identify and come back with a name for you. And of course, methanol analyses are carried out on a regular basis just to see if the dosage of Velcorin is accurate. So overall, Velcorin is not only the product, it's not only the dosing technology, it's also a kind of consulting and full package, service package for the customer. Yeah, that's it basically in a nutshell. Yeah, how to produce hard seltzers applying Velcorin technology.
Thank you, Michael. Very well done. Appreciate that. Appreciate everybody here on the webinar attention. And we've got a few questions. We can kind of jump into that.
Yeah.
From the attendees here. One question we received was, will Velcorin stabilize micro enough that sterile filtration through 0.45 micron filter is not required?
I guess, yeah, I guess this is very much related to the slide I showed with the hurdle concept. Yeah, depending on the different hurdles you apply, yeah, you may not need this filtration step just before filling. If the incoming micro load is already very low, you can control the pickup of microbes in the filling area with Velcorin very well usually. But this is something which should be checked during the plant assessment. Yeah.
Yeah, I think that's a great point, Michael. It's that you know, there is still the opportunity to overwhelm the capability of Velcorin, of course, if the microbial load is too high. So the plant assessment, the trials during the plant certainly utilized well to evaluate that. In some cases, Velcorin could certainly replace this type of filtration, but really further determination would be necessary to evaluate that.
Absolutely, absolutely, yeah.
Okay, let's see here. What would be the shelf life of a product that has been dosed with Velcorin but not sterile filtered? Again, I think this is a good question, probably very specific to your formulation and to your plant. I think shelf life studies of various products are quite variable and really dependent on what you're after here. So this, again, is something that we assist customers with on an individual basis, running a plant trial to evaluate this, sending off to labs to check shelf stability. Really dependent from product to product. Hard to answer that directly. Michael, would you have anything to add to that?
No, agree. Yeah, yeah. I guess for a shelf-stable product, which is distributed under ambient conditions, yeah, for me it's always at the point it's packed and closed. There cannot be any spoiling microorganism in that can or bottle. Otherwise, with ambient condition, at some point it will grow out. Yeah? And usually there's still sugar in the product that will take some days, maybe 20, 25 if it's really growing slowly, but then it's present. Yeah.
Yeah, very good. Here's another question. What media types would you suggest using for screening each critical point?
Yeah, if you do a plant assessment, we very often use orange serum agar, yeah, to see if there is a product spoiled microorganism present in certain areas. Mold extract agar is also very common especially for yeast and mold, yeah. And then plate count agar we usually use to check on the water quality, yeah. And also, yeah, these are the three most common ones we use.
Very good. So in reference specifically to microplating analysis, those are some of the methods that are currently used.
Yeah. And then it's either pour plating, so 10 milliliters of liquid and then mixed with the agar to get an idea of the microbiological load, or if we can filter the product and we know there's only a very low micro content to expect, we would certainly filter it and then put the filter on the agar plate.
Okay. Here's another question. Have you reviewed effectiveness of Velcorin for pathogens such as E. coli?
No, we didn't go into that area because our recommendation is always applying a Velcorin in products with a pH level below 4, where pathogens are controlled by the pH itself. Yeah. So but it might be that there are some data from universities available. I have to double check and talk with our lab here in Germany, and then we can provide additional information to that question.
Yeah, so if we don't get to your question today, sorry guys, but we will certainly follow up with you via email directly. We've got quite a few here. Here's another question here. Interesting. Any difference with diastaticus yeast strains?
Actually, diastaticus yeast, we just run a test at the university in Munich. We have only preliminary results for that, but also that one is in hard seltzer very well controlled with the green application. Yeah, but I know diastaticus is usually one of the strains which has a higher resistance compared to a normal Saccharomyces cerevisiae strain. Yeah, especially if it's somehow adapted to the production environment and has found this specific niche there where it stays for a long time. Yeah.
Okay. Another question here, Michael. So would this mean that there is no need for potassium metabisulfite? Could you use this in sterile raw juice?
So sulfite replacement by Velcorin, basically, right?
Yeah.
Is that, yeah. Yeah, I guess again, coming back to the hurdle concept here in this product, from my point of view, it's enough if you have a Velcorin standalone application here, because anyway the product contains CO2, so during the filling process there's not too much pickup of oxygen, which is bad for the overall shelf life of the product because of its oxidizing activity during storage time. So I would say yes, you can replace SO2 with Velcorin for this product. Yeah.
Yeah. So good question. You know, Velcorin certainly can handle the microbial control capabilities, but one of the aspects of sulfur dioxide or those components is that Velcorin is not an antioxidant. So if you're looking for Velcorin to be used as an antioxidant in replace of sulfur dioxide, it won't have that capability. So we're strictly talking antimicrobial.
Yeah. Yeah.
Okay. Are there any advantages, disadvantages to using Velcorin compared to tunnel pasteurization or heat treatment?
I guess this is depending on the stability of your maybe natural flavors, aromas you put in. If they are impacted by heat, then it could be beneficial to apply Velcorin instead of a heat treatment. For tunnel pasteurization systems, sometimes there is a limit when it comes to the carbonation level of the product. Yeah. I mean, the expansion during this heat treatment and really long treatment time through the tunnel, you could damage your package, or you need to lower the CO2 content. Otherwise, you get overpressure in the can, and this could destroy the package or impact it at least. So yeah, and yeah, compared if you consider a new investment, Velcorin versus tunnel pasteurization, I mean, you can do your calculations, but on product treatment costs overall. But one thing to consider is also the space. For tunnel pasteurizer, it's quite big dimension-wise, while the dosing unit is rather small, and fits maybe more easy into a production environment.
Very good. I've got a few questions here regarding methanol levels I think might be appropriate to ask. One is, deliberately increasing methanol concentration in a beverage seems like potentially hazardous process. Do we follow up with breweries using our product to make sure the methanol levels are being tested? And subsequent to, or another question, is the methanol level from Velcorin a concern? So maybe you can discuss the addition of methanol a little bit.
Yeah, sure. Again, very good question, and those questions are very common. So the methanol occurring from Velcorin treatment at maximum dosage, it's roughly 120 milligram per liter. And considering if you eat an apple, your intake of methanol is 75 milligram per liter. And also with other beverages, you naturally have occurring some methanol in your product. So of course, this needs to be considered, and this is always considered and evaluated also by legal bodies. For example, the European Food Safety Committee, the EFSA, has done a re-evaluation of Velcorin just in 2018, also looking into the methanol levels, and from all the studies and scientific work carried out about that, we can really say it's safe to use.
And by comparison, how would you maybe look at the addition of a 200 part per million Velcorin versus another type of product, for instance, orange juice, or even maybe eating an apple?
Yeah. So can you repeat that one?
So we've talked about, I kind of set you up there. Sorry about that, Michael. We've looked at various additions of methanol from other products, correct? And as you mentioned, the addition of Velcorin at maximum dosage in hard seltzer or other alcoholic products at 200 parts per million, fairly low. Whereas orange juice by itself, or even just an apple, for instance, can produce up to 75 milligrams of methanol. So the addition of methanol in the US for alcoholic products, from a regulatory standpoint, is fairly high. I believe 1,000 parts per million for wine and various products. So we're talking very, very low addition rates.
Yeah. No, true, yeah.
Okay, let's see here. Can Velcorin be used in organic certification?
That's no.
Sorry, currently not. No, not
currently not.
Not available to use in okay. Seltzer, to maintain carbonation levels, need a low temperature. Can Velcorin only be applied at a certain temperature range?
So we recommend, or the operational window for the dosing unit is between, let me get that right, it's 68 Fahrenheit down to 39 Fahrenheit. Yeah.
Correct.
Yeah, maybe some of the products are slightly below 39. Yeah, at least if you would measure the temperature coming out of the carbonation system. But as the product is that cold, and there's a certain transfer period from the carbonator to the dosing unit, there's a slightly temperature pickup. So in most of the cases, we have seen you are, even with the carbonated product, perfectly in that temperature range, to fill it. Yeah.
Very good.
Yeah.
Let's see here. Here's another. Is the amount of carbon dioxide released during the process enough to change the carbonation level of a beverage or carbonate a still beverage?
No, it's far too low. Yeah, you wouldn't recognize that. Yeah. I guess once the carbonation level is below 2 grams per liter, you wouldn't really realize that as carbonation. Yeah, and with the amount added here per liter, it would be 0.16 grams, so 20 times lower. Yeah,
so not really recognizable from a sensory standpoint.
No.
Good. Is it possible to add Velcorin to a bright tank prior to sending to the filter, or sorry, the filler, thus avoiding the need for a dosing unit?
No, you really need the dosing unit, the dosing equipment, yeah, for the inline dosing, yeah, just as the density of Velcorin is higher, yeah. If you would just put it into your tank, it will just fall to the bottom of the tank, and you wouldn't get that mixture you require, yeah. And another factor is looking to the half-life of Velcorin, yeah. Once it's added, yeah, you should be. We want to have the product as fast in the can or bottle, yeah, to really stay active during that bottling process. So these are the main reasons, but you need the dosing equipment.
Yeah. All right, we have a few minutes left. We'll get to a couple more here.
Mm-hmm.
What are the potential safety risks of using Velcorin? So I know that's probably a very common question that we get frequently with users, and I can maybe give a little background to that.
Yeah.
We've been using Velcorin in the U.S. since 1988, and have some longstanding customers that have been using it from the beginning. Some from the largest of the large production facilities to very small facilities. And with over 260 installations, we've focused very, very much so, very highly on safety, and perform safety trainings to keep safety in mind with any installation. There are some concerns with handling just the raw material itself. So when using the equipment, when transferring bottles to the equipment, that sort of stuff, it's really in just the handling where there are some safety concerns that we train customers for. We have yet to date have not had any serious safety problems, mostly due to the fact that we train customers on an annual basis. So we always review and are available for training and retraining to handle it. It's not unlike a lot of other products that are most likely used in production facilities, right? When handled with care and the proper training, completely safe to use. And once Velcorin is dosed into a product, it breaks down. It's no longer a safety concern. So really, we focus on the handling of the raw material. Michael, would you have anything to add to that?
Yeah, no, it's like other chemicals you deal with in the plant, yeah, with peracetic acid, for example, or concentrated caustic solutions. You have to take the similar safety precautions. So I guess for really a beverage production, it's not very unusual to do a safe handling of a product like Velcorin. Yeah.
Yeah, very good.
Yeah.
Okay, let's see here. Let's do one more. What is the typical methanol level in seltzer prior to using Velcorin?
I guess this is depending on your sugar base. Yeah, could be that if you're using grapes, it could be that a certain methanol level is already coming into the product just by that alcohol base. maybe with a sugar or malt solution, it would be zero or close to zero. Yeah.
Yeah, I would assume that they're fairly low with the standard sugar type solution or fermentation method. So
yeah.
All right. Well, it looks like we've reached our time, and I know everybody's time is valuable, so we won't keep you all on longer. But I really appreciate everybody's attention and attending our webinar. And Michael, thank you so much for your presentation. You have our contact information on the screen. Please feel free to contact with any additional questions. For those of you that we didn't get to, sorry about that, and we'll certainly answer your questions to your contact info directly once we get to that point. The webinar will also be posted on our website at scottlab.com if you would like to review it over again. But thanks you all, and hope to see you sometime soon.
Yeah, thanks a lot. Perfect. Very good discussion. Yeah, thank you.